Hello, everyone. Welcome to TGIK. It's Friday, and I'd say I'm happy to see you all, but I'm not seeing you all. You're seeing me. So we've got a pretty busy day, and let me get started with our notes. So we've got, I see Jason in the chat. We've got Jason Hall here today, and we'll be talking about his program. I didn't get a chance to set up StreamYard, so he'll be in chat and I'll be on screen. But maybe sometime we'll get him on screen too. We'll be talking about KCP, which is a minimal Kubernetes API server. And first, let's see. Yes, there we go. First of all, we'll be doing our week in review. So we've got a little bit of notes here of stuff going on in core Kubernetes. For those of you not in the know, there is a shortcut, tgik.io/notes, where you can add any news that you're aware of, or if you want to take notes during the stream, it makes it easier to compile stuff later. And yeah, welcome everyone. So the first one's just a heads up that there are patch releases next week. If you're using Docker Shim, I think that this may affect you if you use Docker Shim and port forward. So hopefully you are not in that combo, but if you are, good luck. And then the last alpha release of 1.22 is out. One of the new features that is part of the new release process is that they're actually building a software bill of materials. Software bill of materials lets you see all the libraries and everything else that got included when building an image. So it's pretty cool to see, Kubernetes is still building and maturing and adding these sorts of tools so that you can be sure that you are getting the software you know about, or that you intended to get. And you can figure out, is it vulnerable to this or that upstream library? Maybe we'll do a future episode on what all that means. So Cappy, there's a beta out of the cluster API. For those of you who don't know what the cluster API is, the cluster API basically is a tool for Kubernetes providers to give hooks so that Kubernetes can say, I need a new machine, give it to me. So there's a cluster API providers for GCP and AWS and for things like vSphere and there may even be a bare metal one where you have to turn on the machine, but then it will get things booted up after that. So yeah, that's Cappy. It looks like it's a lot since the last one. So maybe there'll be a TGIK about that one too. SigNode is also doing a bug scrub soon. So if you're interested in participating in SigNode, this is probably a great chance to get in and figure out, okay, which of these issues are really important and which ones, oh, this has been open for 2 years and maybe it's not even really reproducible anymore. Similarly, in more making things cleaner and better news, GlusterFS and CephFS are not going to be in tree anymore. So I'm actually on my home cluster running Rook, but they have CSI plugins, container storage interface plugins, which means that there's a plugin model and those teams can maintain it without needing to go into the Kubernetes tree and version their software alongside Kubernetes. So that's all goodness. Technologies that we hadn't figured out when Kubernetes launched, and everyone jumped in and said, how can I get my storage in there? there's better answers now, and so Kubernetes is getting a little smaller. I don't know if there's a CAPI for Equinix Metal. Let's see. If we go here, there may be... here's this list of supported providers. I do not see Equinix in that list. There is a Metal 3. I think Metal 3 managed bare metal hardware. So I don't know how all that works, but you can dig in and there's a bare metal, there's controllers and operators and stuff like that. And I'm not going to dig in here right now, but if you're curious, the CAPI book has a whole list of the different providers right now, and you can see that there are like 15 or so. And now it looks like you can do Kubernetes dev, upstream Kubernetes dev on Windows much more easily. So that's pretty cool. As many of you may note, I am using Windows as a daily driver development machine for a lot of things. I do have Windows Subsystem for Linux, and I'm going to be using it a lot today because I don't think it'll be helpful to rake Jason over the coals for stuff that doesn't work on Windows right now. But there's lots of developers out on Windows and some developers who only have Windows. So it's great that it's great to see that coming along as a sign of maturity. And then I only had 2 notes from the larger Kubernetes ecosystem. This is the stuff that's interesting in my personal bubble, but I'm sure there's more stuff out there. If people want to add notes, go ahead. So Lightbend launched a Akka serverless platform, which looks like it's using Kubernetes pods and stuff under the covers. Akka is a... okay. Packet. Good to know. Akka is a distributed actor model built on some fancy and complicated data structures called CRDTs. And basically the idea with CRDTs is you can get changes on 2 different hosts, and you can safely merge those changes later to get to a reasonable and sane state. And so this is a platform where you can go in and you can run little bits of code that, work alongside your data and use these safe data structures to not just serverlessly, do some compute and put it in then a SQL database, but you can actually have your compute scale up and down alongside your data, your compute and your data scale together and store together. And I've literally opened it up and said, oh, that's pretty, and closed it up. So don't know a lot more about it right now, but I saw that it was based on Kubernetes. So that seemed kind of interesting. And then for those of you who haven't been following the SigStore project, related to the software bill of materials that Kubernetes is shipping with, SigStore is an effort to be able to sign, cosign is I think the largest project here, be able to sign your OCI images so you can be sure that when you download an image, it's actually the same one that someone uploaded. So in conjunction with that software bill of materials that we were talking about, hopefully soon when you download a Kubernetes image, you can actually know, hey, it was built from all this software by the Kubernetes maintainers, and nobody has fiddled with it in the meantime. So this is all part of a larger effort to secure the software supply chain. For those of you who are paying attention in the last year or so, software supply chain has become a really big deal. So it's great to see that there are open source tools that are helping all of this along. And if there's no more news, we're going to dig into KCP here. So KCP is a minimal Kubernetes API server. And as you can see, it's very minimal. It doesn't really care about pods or nodes or networking, but it's got some of the core pieces that you can use to build a Kubernetes-looking API. So for those of you who know a little bit about my background, before I moved over to VMware, I worked at Google, and Google's Cloud Run product actually exposes a Kubernetes-like API for the Knative custom resources. And it doesn't expose the rest of Kubernetes. And you can mentally think about it a little bit like, hey, I've got access to this slice of a Kubernetes cluster, this namespace with certain RBAC that lets me see certain things. And then the underlying implementation that Google has for their managed Cloud Run product is actually completely different. It's built off of the same serverless infrastructure that powers Cloud Functions and App Engine, but it looks like Kubernetes, and you could use a Kubernetes aware tool to manage it. So you could use something like kubectl to upload your manifests. And so KCP is an attempt to actually make that simple and reusable infrastructure so that you can use the Kubernetes controller model to manage things, but you don't need to actually do all of the you don't actually need pods and stuff to manage that. You can have controllers that sync things. The first example that they have is a demo that lets you do multi-cluster by creating deployments and then splitting them out across multiple different actual physical clusters. They also point out that you could do this the opposite way. You could give everybody their own Kubernetes API server and their own etcd that they can beat up on, and then sync the resources out using a controller that you run into a common infrastructure cluster, using the one control plane per person, and everyone shares a data plane model. I think the local Kubernetes development, where you're actually like, when we're working on Knative, a lot of the time we're worried about the logic of how does a Kubernetes service or a Knative service map down onto like deployments and network policies and whatever else. And you could actually create these things, create a mock environment using KCP where you don't need the whole real Kubernetes underneath reconciling things. And you would just stick in custom resources for the types that you care about. And it's KCP is not an acronym. It does not stand for Kubernetes Control Plane. And so let's try this. How do I get started? Let's see. We'll start this and we'll go over to, oh yeah, we'll update GoPLS. I'm sure that won't cause a problem. Okay. Let's see. So I think the question was, what are the use cases for KCP? So I think KCP is infrastructure. This is squarely, as an end user, you're probably never going to directly use KCP. You might use KCP within a product, but you may not even know that it's using KCP. There's a little bit of output there. Okay, well, we'll see what's going on there in a minute. You wouldn't directly use KCP, but you could, if you're using a tool like a couple weeks ago, I talked about Crossplane, for example. Where are we? Here we go. You could. So actually, you could use KCP with Cappy. That's actually an interesting use case. So Crossplane is a tool to provision cloud services using Kubernetes. And what they actually do is they have a bunch of CRDs they install, custom resource definitions, and then they use that to provision underlying resources like an RDS database or something like that, using the same controller mechanisms that you'd use for like a, something that's on the cluster, but instead they go and create an RDS instance somewhere else. And there's no particular reason that you need to actually have underlying Kubernetes stuff for a lot of this. So Crossplane is an example of a place where you might have a cluster, you sync out, let's see, using something like Flux, you may sync a bunch of resources into the cluster, use Crossplane to create RDS instances or the like. And what you'd be checking in at the beginning would be YAML of what you want your configuration to look like. And so you have a simple declarative model for what you want your configuration to look like. You check it in, and then it gets exploded out into resources. It would look a little bit like Terraform in some senses, but it would be continuously reconciled. Whereas my understanding with Terraform, not having used it a lot in anger, is that you tend to intentionally do a Terraform apply rather than having it a continuously reconciled process in the background. And it would also be pluggable in a way where Terraform is, where Terraform is mostly a complete stack from provider to language to deployment. You can delegate service access. So KCP is a Kubernetes control plane. So it has RBAC. It has Kubernetes RBAC. That is one of the types that it has. And it has service accounts. So you can do the same access control as you would with Kubernetes. For the most part, I'm going to give Jason just a little bit of trouble here. He checked in some docs, and I chatted with him before this. And so this is describing the multi-cluster demo. KCP doesn't currently support validating or mutating admission controllers. So if you have things that you want to use like OPA policy for, that won't work with KCP unless you extend KCP to start supporting the admission controllers. Let's see. Well, this is just saying fail to list, so I'm going to guess that we can. Let's see. So these are all the types that we have in the cluster. So it looks like we have config maps, we have events. Interestingly, we have limit ranges. Is Limit Ranger installed, I wonder? Let's see. Command KCP. So this does some stuff. Oh, should support admission webhooks eventually. Okay, I thought it was a design goal not to. My mistake. It sounds like KCP will eventually support admission webhooks, which is great because, yeah. Oh, and Jason is, well, you can have limit range objects and not actually do any admission control on them. Oh, you need me to zoom in. Thank you. Is that clearer? I always forget that not everyone has a great screen and great eyes for it. So we've got resource quotas and limit ranges, and I don't know if those are enforced. Is this? I'm wondering. It looks like a lot of this is pulling in Kubernetes control plane stuff directly. So this is mostly aiming to actually build with the Kubernetes code with a little bit of extra stuff, not to fork more than is necessary, which I think is a good decision. Because core Kubernetes, it may feel like the KEP process is really slow, but there's a lot of motion in that repository. So keeping up with it is challenging. Oh, are there two different API versions for events? That's exciting. I was just noticing that events were in two different API groups. So I don't actually have. I'm going to take a look at this cluster controller a little bit, but then I think I'm actually going to go off and see if we can get authorization working. Oh, let's see. We get somewhere in here. I was told to find my kube config here. And since this is going to go away real soon, I'm not too worried about looking at this. And right now, it looks like we have a user with token-based authentication. And oh, that's cute. Using IPv6 addresses. KCP does not really compete with K3S. So for those of you who aren't familiar, K3S is a project started at Rancher where they've taken the Kubernetes API server, they've replaced the underlying storage, which is etcd on Kubernetes, with MySQL. And so they use MySQL for all the storage layer, but otherwise it's a complete Kubernetes. So it still manages nodes and pods and services and endpoints. And if you've looked at how pods and pod labels and services and endpoints all line up, you can kind of imagine that it would be hard to build a Kubernetes that had half of those and not the other half. The network connectivity is pretty deeply tied into the pod management. Oh, it's SQLite. Okay. I stand corrected. It was some form of SQL, and I couldn't remember which kind. But yes, so they have an alternate backing store, which they feel makes it easier to administer and higher performance. But it's really a different approach, and you could imagine combining the two approaches. So if the K3S patches and the KCP patches were mostly compatible, you could imagine running a KCP where, okay, yeah, it sounds like they have an etcd shim. So you could use the etcd shim with KCP. I think it's a future plan to support an external etcd. So you could have SQLite, etcd, shim, SQLite, etcd, shim, and then KCP, and avoid actually running etcd at all, but still provide a Kubernetes compatible API. And so what I was actually going to do here is I was going to see if we could use auth0 and Kubernetes. So this is a walkthrough of how to set up auth0 so that you can authorize to a Kubernetes cluster. And this would be a step towards if you actually wanted to run KCP for a service, like if you were going to provide Crossplane as a service or something like that, you might want to do auth using something like GCP credentials or Microsoft credentials or something like that. And so this is a way to get in and do that. So I've actually gone through the make the auth 0 steps here. And so I may need, and unsurprisingly, since they are an auth people, they support a lot of different login mechanisms. So I created an app called KCP here, and so we're going to go on to step 2, which is where we set up and configure Kubernetes. Okay, looks like I had a brief network connection hiccup. So let's see. We will. Let's see. So we've got KCP running over here. And it looks like this takes some commands like start. And let's see, we don't need this anymore. And we does this support the extra args? I guess the easy way is to find out. OIDC issuer URL. Does not know extra config. Let's see. There's client config. Let's see. One thing I'm wondering is how old this is. 2017. So let's see. Kubernetes OIDC. Configuring the API server. Oh, it looks like these flags have changed. Awesome. OIDC issuer URL. So it looks like the API server will only support a single issuer, but since we're using auth 0, I can use my Google auth to auth 0 and then auth 0 to auth to the cluster. So let's see. Looks like this is the new parameter name. Yeah. So now let's see. Let's see. So we're going to see oh, well, this is ancient. That is in client. Oh, you see the options. The option struct. And oh, I need yeah. So GitHub code search is not very good here, and it doesn't recognize these are all different types. Well, let's try looking a little bit at this demo first, and then I'll probably try hacking a little bit and see if we can find where the OIDC config comes from. Oh, that's under staging too. Actually, I bet if we do go mod vendor, I should be able to look for that URL in here. OIDC issuer URL. Here we go. It's this built-in authentication options, add flags. While that is figuring out what is available, let's go back. And so this is defining a new cluster type. So this is, we're going to go through the official tutorial for a moment or two while I go digging that out. API version. Yeah, okay. So this is just a CRD, and the spec has a kubeconfig, which I think is probably just a secret. YAML serialized. Oh, it's a kubeconfig file. Oh, that's interesting. Because your kubeconfig may have access control secrets in it. So I probably would have had it be a reference to a secret, but it's also a demo. So please don't run in production. Let me actually go over here, get this up, and then this up. Okay. So let's see. We're going to say go run command KCP start. Because if I recall correctly, that takes over my terminal. Oh, that's very quiet. There we go. What does this say up here? Loaded one mutating admission controller successfully. So, oh, but those are the built-in ones. Those are not the external webhooks. And it looks like it's just going to keep complaining that it doesn't know about services and endpoints. So we can probably just keep going from there. And I'm guessing that's some of the... did I mention this was an early project? This is some of the code that KCP would like to clean up so that they can just say don't watch services and endpoints. But this is the architecture of things. So now this is the README. Oh no, this is the architecture README. Okay, let's look at the demo again. This is all demo. Here we go. So we define a cluster CRD type. This looks awesome. Let's see. Yes, I know that I've got new lines in there. There we go. So one thing I'm missing in this demo is so we talk about how we get the cluster CRD in here. Oh, it looks like we can create multiple logical clusters by pointing things back. But I don't see the actual commands I need to run. So I'm just going to take a look. Create kind clusters.sh. Okay. Let's see. Let's see. So we do kind create cluster, and then oh, that creates. Oh, I guess if we look in the demo, start KCP for demo. Aha. Let's see. So let's see. This is. I do that. Start KCP. Start the cluster controller. Kubeconfig equals go run cluster controller. Kubeconfig is admin kubeconfig. And then I think there's one more argument, which is deployments. So I see this is complaining that it can't find the cluster. And I'm just wondering if we actually, I didn't see us load a CRD into the cluster. So yeah, I don't see clusters in here. There's a deployment.yaml. Clusters. Create kind clusters. I'm wondering if... here's our custom resource definition again. Cluster example dev clusters. So apply config. So this will create us a new custom resource. And then, oh, unable to cluster.example.dev. Okay, that was apparently a momentary, we observed etcd in the middle of reconciling things. Now things work, and now we have a cluster resource type here. So yeah, this is one of the fun things that you get when you're using etcd as a backing store is, unlike if you're using something like SQL and you do a alter table, like you will, every other query will see either before the alter table or after the alter table. But because Kubernetes is eventually consistent and it's doing this reconciliation process, you can actually observe the cluster while it's in the middle of adding a new type, and that usually doesn't go well. It looks like that made this happy. It's able to list the clusters now. And then we run a deployment splitter as well. KCP root. I'm wondering, Jason, I see you have two different ways of defining kubeconfig in here. I think that probably only needed to be one. And it looks like the only argument to deployment splitter is a kubeconfig. So let's try this. Go run command deployment splitter kubeconfig equals KCP data KCP data admin kubeconfig. Okay. Failed to list. Oh. It looks like we need to load a deployments custom resource as well. Let's see. I wonder if you have one of those over there. Oh. If I connect a cluster, the cluster syncer will load those in as custom resources. But it looks like we have something in CRDs that will do the trick. So let's start with that. Kube control apply -f trip securities. Okay. So cluster controller will copy the types that it knows about. But if I connect it to like if I connect it to a cluster, this is my personal cluster where I run stuff that has all of these types. It's not going to sync them all over. I need to tell it the specific ones to use. I think that's probably totally fine. Wow. And that did not. There we go. Don't know what happened with the rendering before. But it's not going to copy all like 80 of those or whatever it is. Okay, so now it looks like we have deployments. And then the next step in the demo is, whoops. We create these clusters, and then we get the syncer up and running. Oh, the syncer will do the type syncing. And it will sync things up and downstream, and only if they match a certain label. So I can say, okay, only put it in my cluster. And then, let's see, it will sync things down, and then it will copy the status back up. So you can have deployment in like 3 different clusters, and then have all their status in one cluster, so you can look at that easily. And so we can actually say, okay, create this deployment, and it will create new deployments in cluster 1 and cluster 2. It will show you how many are ready. And it will total up the number in the upper cluster. So you can say, oh, hey, I have 15 of these all together. And it looks like the deployment splitter will intelligently figure out how many to run in each cluster. So I can say, I can run something like a horizontal pod autoscaler in my KCP cluster, horizontally scale, okay, I should have 15 deployments or 15 instances, and then the deployment splitter will figure out how to align them down to lower level clusters. If you're all running in the same cluster, that would work really well, or in the same like AZ or region, but you need different Kubernetes clusters for redundancy, or you've got different data centers, or something like that. You could improve that. Keep KCP's version, keep control of API server. So kube control works a couple versions forward and back. So let's see. I should be able to say kube control versions. Kube control version. And my client version is v1.21. Since I built this from source, that's an interesting version number, but it's close enough to be compatible. And so in that other cluster over here, You can see that my client here is 119 and my server is 120. So these should all be able to interoperate with each other because they're reasonably close in terms of version. So you could do the same thing with cron job. Daemon set actually feels like it would be really powerful because you can have a set of daemon sets, like your all your monitoring agents or all of your load balancers in a single KCP cluster, and then replicate it out to multiple instances and kind of have a policy that says, hey, these are the agents we have running everywhere. And then a bunch of other ideas about what we could do. So let's go back. I've got about 30 minutes or so at least. And so we were looking in authentication.go and trying to figure out where all this is called. Let's see, go to references. Add flags. Let's see. Is there a way? Options. Let's see. In control plane options, add flags isn't there. Interesting. So if we go back here, I see the flag that adds the OIDC issuer URL, and it's called from here. Let's pin this. No references to built-in authentication options. I don't believe that. Let's see. Oh, this is the file we're in. So, server run options. Let's see. And then we wanted the KCP command. So, new server run options. See server options. Secure serving. Add flags to a flag set. Do we already have a flag set here? Listen is start command flags. Okay, maybe we want to this. Yeah, here's our server run options that has an authentication field. New server run options. This is with all. New built-in authentication options. Let's see. I do not want to upgrade my Go right now. I will just deal with searching. S.oidc is not nil. Then we add all of these flags to the flag set. OIDC. Wait, this feels backwards. If the OIDC is not nil, then we add all these flags, but it feels like we already have some of this stuff. Well, I guess the simple thing we can do is we can hard code it for right now. Authentication OIDC client ID. So let's see if we're over here following this example. Issuer URL, username claim, and client ID. Client ID, username claim, and issuer URL. Let's see, we're going to go back over here and oh, while I'm doing this, do people understand how OIDC usually works? The goal for OIDC is that you can have a identity provider like Google or Auth0 or something like that who can vouch for your identity to some other service. So and so the goal here is that we're going to be able to take a token from Auth0. I'm going to copy this over. And we're going to be able to go to Auth0, get a token, put it into our kubeconfig, and use that to authorize ourselves using our Google account to the Kubernetes cluster. And you could use this for the dashboard. You could use this for Octant or something like that. Actually, I'm wondering, Jason, have you tried using Octant at all with KCP? I'm wondering if it works or not. I think that is it, but let's go back over here. Make sure, yes. Yeah, I was curious, but let's see if we do this, and then let's see over here. I was running KCP, make everything sad, and start it again. Yeah, I don't know how well Octant will work if API resources that it expects, like deployments, aren't there. You could also see that as, RBAC saying, oh, I won't let you see it. But if you go to like API versions or API resources, then it seems like you might. Remote TLS error. Interesting. Yeah, I might try to do that. The challenge right now is I'm on Windows subsystem for Linux, and so I'm not actually sure how to get my web browser to hit an octant running in the right place. I don't have a web browser on my Linux machine. Uh, yeah. Um, who knows? Maybe I will spin up an extra copy of KCP and see if it'll run on Windows. You knew it was coming. Okay, so we've done this. Let's... I was hoping there was a duplicate, but... so... oh, we can still call that loopback. Let's see. Just call me. So we go over here. This is all about just setting up your cluster. You have a working cluster. Test OIDC connect tokens with kube control. Oh, coming soon, of course. Deploy Kubernetes dashboard. DC proxy. So this is showing how you could use the Kubernetes dashboard with OIDC tokens. My understanding is that that's not necessarily considered a great idea to have a web service where you're taking your auth tokens and using that to get like administrator access to the cluster. I like the octant approach where it's actually a binary on your machine using your kube config more than browser auth for running a real Kubernetes cluster. Now, on the other hand, this is KCP. I can't start a Bitcoin miner using KCP because I've got no nodes. Like, there's no compute available for someone to go and latch onto. So let's see. We're going to go here. This is OpenID. This is the Auth0 OpenID tool for sort of getting stuff to work. So, oh, that's not the right URL though. What is this? Aha, here we go. We just go here and we can set our configuration, and my auth domain is evanade.us. And then I need to fill in the right client ID because that's picking up from my default app. And now here comes the juicy stuff where I paste my client secret that they carefully hide from you into YouTube. And after this, I'm going to delete my client secret, so I'm not worried about it. So now we'll do the request to do an authorize. And so this is Auth0 sending me to log in. I can say continue with Google. Here's my account. Now, so one of the exciting things about OpenID Connect, I've just gotten a refresh token, but it's bound to the audience of this application. So if you take it somewhere else, that token shouldn't help you log in anywhere else. So now we can exchange that access code in for a for an ID access token, and now we can take this whole long jot and verify this is the encrypted information that you get. And you can see in here there's an audience that is unique to that client key. So it starts with JMAR, and this starts with JMAR. So if you're not that client, you're supposed to ignore this jot. And so let's see. Now over here, we're going to try sticking in, I think that's the right token. Let's see. Somewhere here. This is OID. Use the token option. Okay, looks like I can say kube control token as well to do that. So let's see if that works. We're going to go over here to our terminal, and let's see, kubeconfig equals KCP data, Google creds, kube control version. Okay, I get forbidden from the server. Let's see, bad cert. I'm not sure that's related. Oh, I bet these are the old controllers running that are adding these complaints. So let's see. That seems quieter. Now if I do this, I get no message over here. Forbidden details, unexpected server response. Is there a dump HTTP option? Request server skip headers. Standard error token. It looks like I just need to crank the verbosity to 10. Woohoo! So here is my request. Authorization bearer. V equals 9. Great. Okay, so I guess maybe 9 takes off the stack trace. No, the stack trace is still there. Okay, well, so we're trying this request, well, I guess the nice thing is I now have a curl command that I can try running just that. Oh, nice. That gives me all the TLS stuff, and then I'm getting a 401. Oh, yeah, but if I say the authorization is masked, that's almost certainly not going to help. Let's see, if we go back over here, this is, this is updated at this time and expires. I do not know how to read. Let's see if we do this here. Does it work? Okay. I do not know how to read that timestamp. Oh, but it's issued at this time and is good until, it looks like it's good for an hour. So that shouldn't be the problem. I'm going to assume that this isn't supposed to be the access token, but we'll try that first because that's real easy to substitute. Nope. Yeah, I always have to look up the syntax for that. But thank you. I will try that as soon as we've tried this ID token again. Let's see. Copy this. That was a nice short request. Oh, I got a 403 as opposed to a 401. Oh, this is working. I'm getting authorized. But I don't have permissions to actually use anything because there's no RBAC for me. Oh, that's exciting. Okay. And yeah, let's see when this expires, just for good measure. So IAT is issued at, EXP is expires. For those of you who haven't spent your time looking at OpenID tokens. Actually have to use all the characters. So yeah, this is good for a couple hours. So let's see. Now I just need to figure out OpenID tokens. How do I actually name these people now? Using RBAC authorization. Let's see. Create cluster role binding. User. Yeah. Let's see. Cube control get cluster roles. Let's see. Ooh, system basic user. That looks good. Oh no. Maybe edit. View. View's even better. Okay. Control create cluster binding. Event test. Let's see. Cluster role. View. I don't want the service account one. I want -- user equals. Oh, one thing I learned that is fun and exciting. Case matters here, and depending on your Google account, it may not all line up. In this case, it's lowercase. There are other APIs where you'll actually get things capitalized sometimes instead. And that was a huge pain when I had to deal with it. And let's see. So if we do this, cannot get path version. I almost did cluster admin, but I figured I didn't need cluster admin to figure out if things were working. And Google, let's see, GKE cluster I'm looking for the Google Compute Engine RBAC documentation because they will tell me how to spell my user. Probably. Except that it looks like it should be that. This is all documentation on how to do it, and how things get wired up. This looks like I should just be able to say user and that. Oh, that's a great question. Get user let's see the curl again. User cannot get path aversion. Well, I'm going to go do the bad part, and I'm going to see, oh, hey, what happens if I say cluster admin? And I know that the answer is going to be the same thing, but cluster admin. Let's see. Yep. My VMware login is M&A, so I keep adding an extra letter over what I needed here. So the auth is working. And we know that because I'm told this user cannot get this path. But it seems like delete func returned. Setting cluster name. Admin in append list item. So let's see. Do we get any new logs? We don't get any new logs. I'm a little bit suspicious about permissions here. Yes, the default context is pointing to the KCP cluster. You can tell that because I can say kubectl API resources, and I get just this list. But this curl command is also pointing at the cluster because it's got this localhost IPv6 address. It's kind of cool that you're defaulting to IPv6, but since it's localhost only, that should work unless someone is not dual stacked at all. And I'm guessing that you're just using whatever you get out of the Go libraries. Auth is asleep at the wheel. Okay, so we have the cluster role resources, but maybe authz is not actually working. I'm trying to think of how we would easily test that. I guess we could create a service account and try reducing its permissions. We have no service accounts right now. Oh, because we were running all the controllers as the loopback user. So they were all cluster admin. Yeah, I would have to dig a little bit to figure out where that auth is. Let's see. If I look for the string loopback, Token loopback client config. Oh, we're going through a loopback client. Wait. But we know that so we create two wait. So I see we're creating two contexts here. If I do a kubectl config get context. Oh yeah. Okay, so we have a user, but they're the same auth. So the fact that they're named user doesn't change anything. Generic API server. Yeah. Mission control. Install. Oh. Register the cluster CRD. Oh, cute. It looks like there's an install cluster controller. So it looks like if I pass -- install cluster controller, I don't need to install those CRDs for the demo. That would be another way if you wanted to make the demo a little bit easier to run through. But eventually you probably want to take that out. Create. Oh, so actually if you say install cluster controller, it will put the clusters controller in as part of the main binary and will actually start it at the same time. Client configs off the info. We get server from here, which we get from the control plane options. We set the cert directory and set the ports, and here's where I just whacked in the authentication stuff. It's possible that there's more authentication stuff that I didn't. Let's see. Password file. It'd be nice to have the webhook stuff working too. Yeah, so Jason is commenting in the chat that you can actually build KCP in your controllers into a single binary for actually running things. So you could, if you wanted to have, for example, hey, this is a service, a web service that uses KCP and manages, I don't know, like Akka serverless that we were talking about earlier. Oh, do we need the audience? We have the client ID, which I think is the audience field. Dot authorize. I don't think there is an server options dot authorization. Yeah. this tutorial about how to do it is pretty old for the Kubernetes, and it suggests an authorization mode, but it looks like that's oh, authorization modes. Let's see. There is an authorization mode flag. Oh, to enable RBAC, start the API server with authorization mode equals RBAC. Authorization mode. Built-in authorization. Authorization.modes, it looks like. Wait, this is part of built-in authorization options. And where does that show up? Apply authorization. Oh, somewhere up here, I thought I saw a bunch of flags. Webhook. Oh, this is an authentication to go to still. String slice. Built-in authorization options. Here's the struct, new built-in authorization options. No, that's can't be it because it takes one of these already. Built-in authorization options. Let's see. Auth modes. Mode RBAC. Let's see. Yeah. I've got to run soon too. So we got close. We actually got authentication working. We just didn't get authorization working. But I'm excited to see where KCP goes. And this is one of those cool infrastructure pieces that literally is going to be under the covers, and you won't know, exactly how people are using it until you see, hey, there's this API, and it looks like it's Kubernetes, but it scales in a completely different way than your normal Kubernetes clusters do, because it doesn't have to do all the work of services and so forth, and it's farming that out to some other infrastructure. So I'm excited about this as a way to sort of build, new cloud services that look like Kubernetes. I'm going to try one more thing, and then I'm going to sign off. And the other thing I'm going to try is authorization mode equals RBAC. And that's not going to work. Yeah. Okay. Well, I think maybe Jay or Joe or someone is going to be there next week, but I will probably see people in a couple weeks. And this was a blast. So thanks for hanging out with me.